Well, hello SINUMERIK Nation, and welcome to Simply SINUMERIK Live. I'm your host, Chris Pollock, and today is our much-awaited Christmas special. So I want to just say hello and thank you to everybody who's joined us today, and if you haven't made it, hopefully you get a chance to watch the recording. I must admit, I do look forward to this special or this event probably more than any of them through the year. I just have a lot of fun kind of getting ready. This is certainly a time for us to just reflect on the past year, decompress a little bit, have a little bit of fun. So this year should be no different than past. So what we're going to do today is we are going to machine a little ornament. So for those of you that may have spent time with me in past seasons, you know that we try to make a little tradition of machining an annual ornament. Each year, I try to do something a little bit different, and this year certainly is nonetheless. So what I wanted to do is I wanted to make just a nice little two-dimensional kind of profiled angel ornament. And in looking at it, I started to think, well, this is always a little bit of a challenge when it comes to work holding, right? I wouldn't traditionally hold this in maybe a vise. If I was to use strap clamps, they'd probably be in the way. So how would I effectively hold this ornament to machine? Now, I've actually used double-sided sticky tape, which actually works quite well, to be honest with you, just on a little fixture plate. The challenge is getting the parts off of the tape. Either the tape doesn't stick well enough and the parts start releasing on their own during machining, which is never great, or you have to rip them off and do an extensive amount of cleaning getting the tape off the back of it. So what I wanted to do, and I've wanted to do this for quite some time, is I wanted to build a vacuum chuck. I wanted to be able to hold this down with vacuum so I can machine all the way around the perimeter, do any detail I want, and then when it's time to release, just shut the vacuum down. So that is what I'm actually showing you today. I designed and built a vacuum chuck specifically for this application. So the way it works, and take a little look at my setup here. This is my vacuum chuck. What will happen is I have a pump running in, pulling vacuum, some ports, and it's going to hold down our material. Now, the design of the chuck, pretty simple, not a lot to it. Jump to this page first. So it's a two-plate design. The base plate is what you see there on the left side of the screen. So that just really gives me a cavity area for vacuum, some kind of a chamber. And then I have a top plate where I have a grid of holes that allow the vacuum to be ported through, as well as some perimeter 1/4-inch reamed holes for some dowel pins for locating my part. The two bolt together. That little groove you see on the left bottom plate, that just allows me to put a sealant in there. I used a little RTV just to seal the two together. There's a 1/4-inch NPT on one side of the bottom plate, and that will bring my vacuum up through. Now, from there, once I have the plates set up, then I put in a grid of holes on a 1-inch spacing. And there's a couple different ways you can make these vacuum chucks, for sure. But one of the ways you see common in the industry is there are just machine groove channels. And with these groove channels, what you can do is you can use some very simple single-sided foam tape. This would be traditionally used for any kind of seal, like a door seal or whatnot. And then you can make an outline of the perimeter of your part just on the inside of your finished edge that creates a sealed area. Now the challenge with this method on a part that's organically shaped like our angel is it would be tough to kind of form out that area. Now I could kind of just do some little boxy areas and try to get some vacuum into those sections. But what I decided to do is I decided to do something a little different. I set up an entire mat of 2-inch foam, again same single-sided sticky tape, on my plate. And then I was able to use the grid of holes to open up which ports I wanted to use that for. Now the grid of holes on my design actually holds two primary purposes, because not only can I open and close different ports just by adding set screws with a little bit of Teflon tape to seal it off, or opening them up for my vacuum locations. But with this fixture plate, I can take all the foam off, and since it's tapped, I could actually put like Mighty Bites there. So I can use this fixture for holding things other than the vacuum. So I can kind of go back and forth. It just makes it a little more versatile than just being strictly a vacuum chuck. Other than that, it's really the next step is figuring out where my vacuum is going to have to come out. So here you can see the kind of the outline of the angel. That was actually from the end mill when I was cutting some parts. But if you can notice, and I don't know if you guys can see, I can try jogging the machine down a little bit. Might make it a little bit easier to see. But there is an inside line or edge. Oop, get my shadow out of there. So this line that I cut is actually offset from the outside finished edge of the profile by 200 thou. I needed to know here once I got to the machine, I modeled all this up. It was easier to know when I nested it in the CAD space, but I truly needed to know where my parts were going to lie so I knew which ports to open up. So to do this, it's actually kind of an interesting little trick. So I used to work for a company and we made our own stickers for the machines that we built. And one of the ways you make vinyl stickers is you use like a pen plotter, and instead of a pen, there's a little blade or a little knife. So I ordered up one of these little pen plotter holders and knife sets right from Amazon, dropped it in a drill chuck, and then I created a little part program that's going to go around the outline of my part. I offset it in by whatever distance I wanted the foam to be set to, in this case 200 thou, and I ran it. Now, certainly your machine has to be set up to allow you to run feed moves with the spindle not spinning, because I would not want to spin this. But by doing this little assembly, I can cut out my foam, right? So I can make this little edge here, cutting my foam out for me. And now I have two options. So I can do what I did, which was just opening up these ports, or if I feel like I need a bigger vacuum area, I could then cut out all of this foam on the inside, allowing me to have this entire cavity open. I found in playing with this, the ports were more than enough to hold down these parts. But if I was getting these shifting and I needed a little more area, I would then start to cut out some of this foam area in the middle to allow me more vacuum areas. Now, with that vacuum chuck, the next step is how do I actually create my vacuum? So there are all sorts of pumps on the market. What I actually decided to go with was a very simple AC evacuation pump. This is a Robin Air unit. It's their 5 CFM 2-stage pump. But this allowed me more than enough vacuum to pull and hold in my parts. So that was readily available just on Amazon. They have all kinds of different models there. The 5 CFM seems to be pretty much the highest rating of the kind of the AC vacuum pumps. If you're going to do something on a larger scale, more ports, more fixtures, you're probably going to want to go to a little bit larger of a pump assembly. But I tell you, with this vacuum pump, I was amazed how much holding pressure I have. Now I have the pump mounted kind of just behind me, so I'm just going to plug in my 110, pump comes on. Now the one thing you're going to want to add is, I don't know if you can see it here, this little gauge. This is super handy, and it's handy to have it up by our fixture plate because this is showing me that I've come to pressure. And depending on my setup, I'm going to see kind of a nominal pressure here, or vacuum, shall I say. It's an inverse of pressure, right? That's going to indicate to me that I'm in clamp position. Now, if you look, I can put all kinds of pressure on this part, and it is holding quite well. If you were to kind of wedge under it and start pulling it up, if you notice, the gauge starts dropping, telling me I'm losing vacuum. So while you're running, you can certainly keep an eye on that. If you start to see it dropping, or you're doing a new fixture setup and it's just not pulling, then I can start to go around and figure out where my loss is. You know, the big player here is just a closed system. So if I have any areas where air could escape, in this case air pull into the system, that's where I'm going to keep me from building my pressure. And then as she settles in, it'll build up a little bit extra pressure here. But it is amazing the force that we can put on that. And other than that, it's really pretty straightforward. So I just plumbed an air line, kind of through out to the back of the machine where I have my pump, and away I go. Now at this point, I can shut it off when it's time to remove a part. Now that you'll see the gauge drops, so it takes a little while, you know, maybe 10, 15 seconds for me to reduce enough pressure to be able to get this part to release. But that's really, that's all it really takes. And now you have a system where I can pretty rapidly adapt this to all kinds of different shaped parts. Now, with that being said, we're going to be cutting our angel. So why don't we get one cutting, and then I'm going to show you a few unique things that I've done to the part program for this specific job. So I'm working from the upper left corner. I've set it up to be able to machine 6 parts. But I wanted to kind of show you how I might methodize a program if I was working from, like multiple work holdings, maybe multiple vices, multiple fixture locations, maybe a tombstone setup. How there's different ways that I can kind of structure and support that program. So from the programming area, I built a main program, and a little further down, we're going to dissect this in a second, I now have different subs that I'm calling. So in this case, it's going to machine a complete part in one location before it moves to the next. If I was doing high volume, I might have wanted to optimize my tool changes. Here, I wanted to show you a little different structure. Now, one of the things that I did find, you're going to see in the first operation, was I do get a little bit of a variance when I'm dealing with my workstations, because if you can imagine, obviously I'm on foam, so there is a little bit of a deviation. So for me, the part profile wouldn't really matter if I varied, 3/4 thou, but the engraving does get affected quite a bit. So I'm going to come down, I'm going to do a quick little Z set with my probe. That's going to adjust my work location, and then I'm going to go into my actual tool path. So each of these are just given subs. Okay, now in the beginning, and we'll talk about this here more once I get this running, but I do have a little variable that allows me to tell it which part I want to run. We're going to go grab our part probe. Going to come down into position. We're going to probe the top of the part. Now I am writing it to my work offset, and I'm specifically writing it into the wear, so there was a little adjustment there, 5 thou on that location, and now we're in cutting the part. So for this part, I did do a little adaptive style milling. I'm clearing out the pockets that you see on the angel, and then we're going to go back and take a small tool, finish up some detail, go around the profile. But what I want to show you while we're cutting is I want to show you the part program a little bit. So if we jump over, I did create just a second one here that we can play with, so we're not messing around with the actual part we're running. But this is the exact same structure. So in the part program, first thing I wanted to do is I wanted the ability of jumping from one job or one location to another. So this way, maybe for whatever reason, it's 3 vices and I want to just work on the middle vice. Maybe I gotta get into a set of jaws, something's going on, I want to jump over, or maybe I was in the middle of a run, come in the next day, I want to start from the 3rd position over. So you can do that pretty effectively with using what's called a local variable. So that's what this workpiece, this underscore workpiece is. This is a variable I'm defining inside the part program. It's an integer, so it means it's going to be a whole number. Oh, you jump back so you can see what I'm talking about. So there you go. There's your workpiece variable. And again, it's an integer, that's the int, it's a whole number. And then I can just tell it which part or which location I want to start from. So by just simply changing this number, if I go simulate the job, it's now going to jump to that work location. Now, how does the mechanism work? Well, once I've set this workpiece, I do some simple, start kind of safety start pipe positions, retract in Z, my safety line. But down here, forget about this first set of conditionals. I'll explain those in a minute. But down here, I'm going to jump down and say, okay, well, if workpiece equals a value of 1, you're going to go to this thing called part 1. And so on and so forth, right down through the end. So each part is going to jump to a separate label. And that's really what that underscore part 1 and part 2 is. It's just a label in the part program. In the very end, when I hit 7, that's going to set me to the end. Now you're probably going to think, well, how does it ever hit 7, right? I just set it to 1. Well, as we go down through the program, you're not only going to see where the jump condition occurs, but you're going to see how I then index this value. Okay, so let's say, for argument's sake, I wanted to run part 2. Now, the initial program was set up, upper left-hand corner is a 0, and I need to now move all of my work holding over some value. So as I jump down to a label called part 2 right there, you're going to see that I'm looking at workpiece number 2 is being set here. I'm doing a trans command. That's going to clear any 0 shifts I may have had, but my trans with my X value allows me to shift my coordinate system. So it's called a translation or a transformation, and it's going to push the 0 4 inches over, and I'm not moving the Y because I'm doing the top row. And then I jump down to a label called start. And start's going to be common for each routine. So as I step down through, you see on part 1 up here, there is no trans shift because that was my 0 when I programmed it out of CAM. Part 3, I'm just moving my X but the full 8 inches. I have a 4-inch kind of pitch between parts. And then when I go to the lower row, I had a 5 1/4 drop to each part. So eventually you'll see even a transformation for each one. Now, I used the trans between each one to cancel any previous shift, so my numbers are always relative to the 0 of my part, my original global 0. Once I get down to the final jump, this is where I get in and I tell it, hey, I'm going to run some toolpath, right? So my first one is going to jump into my nice little G-code program. This is going to do that area pocketing clear. So you can see here in our little mold maker view, this is where it kind of pocketed out those features. Next one handles all my 1/8 inch tool stuff. That's what it's doing right now. It's cutting the profile here. It's going to cut that all the way through, so that part will be free when it's all said and done. All right, so if we take a look at this one, so there you see I was clearing out a couple little areas where my bigger tool couldn't reach, my nice little pocket up top, and working around the perimeter. And then I show my final. This would be where I take my engraving tool, which is a chamfer mill. I engrave it, I do a quick little deburr, and I put a little spot on the top where I can go back and finish drill. I do that as a secondary operation for just a little line or a little string to be able to hold my ornament up. So all this is common to every job I do, but the beauty of how I have it structured is this next little line. So underscore workpiece is saying, hey, set the workpiece variable, this local variable, equal to whatever it was plus a unit of 1. So as I finish each job or each work holding, I'm going to index it to 1. So at this point in time, right there, I say, okay, now I want you to jump back to the beginning of the program. And I get this nice little loop created, all right? So let's say I cut the first one like I'm doing now. When I get fully done, it's going to add 1 to the index. I'm no longer going to hit this top variable because my jump actually went to N1, right? If I look back down, this quick little jump, I'm going to N1. I could have gone to a label. In this case, it was just easier to go to a line number. So it jumps up. Once I jump up there, I come down and I say, oh, okay, well, what is my workpiece? Oh, it's number 2 now. Let me jump down to 2, and now I have this loop, and it's triggering. So this is a quick, simple way that I can now move between different work holding locations. And this whole thing is going to keep going until it says, oh, I'm at 7. Well, I don't have 7 parts to cut, so this is where I jump to my end, which is at the very bottom of my program. There's my end. I clear my workpiece counter as I'm done, so I'm going to be starting from the scratch again. I make sure I clear any previous transformations. Let's go to auto. So I had put a quick little op stop here. So this would be where she would now move to the next part. And you'll see it'll do that loop. So I'm going to probe it now, but it's going to probe it to the right. Quick little check. Any variance in the top of the part. So I think it was +5 before. Yeah, 5.4, it's pretty close. I think it adjusted a couple tenths. When I get to the back row, I see a little bit of variance. And now we're back in and running. So now it's done the whole loop. Internally, it's now got a trigger. So now we get to the point with the little R variable. So here it's cutting. So let's say me as an operator, I hit reset. I shut off the part program. Maybe I jog up, had to get in, clear some chips, do something. Well, I wanted a little bit of logic in the program to say, hey, if something was interrupted before it was completed, I want you to always go back to that point. No matter what I put the workpiece counter at, that's going to kind of override the state of the workpiece counter. So this way, if I had operations that are maybe very dependent on a previous operation, I can now force that to have to complete. So I'm really just taking that pressure off the operator for him to manage it. So let's see what happens here. So we can go into the program, we can go into the one I'm actually running. Here you see my workpiece counter was at 1. Well, at some point in time, so in this case, I jumped to part 2, right? So at some point in time, this was my jump right here that made me to point 2. I actually set an R variable, and I specifically used an R variable and not a local variable because once the program gets reset, oh, you can't see my program, I'm sorry. So here's the R variable. So I'm down in the part 2. So once the program gets reset, my local variable would be cleared. I would lose that. And I want to maintain this. So this is where I'm using an R variable. So I'm just simply setting it to 2. And then we go and we do our start, right? So it jumps down. And we come down into the start. And you see right here, when I'm done, fully completed with my program, I'm going to go to, or I'm going to clear the R variable to a 0. However, if I never get to this line, now, if I look at my R variables, it's holding some value there. So that first conditional that I added in this little program right at the top, right here, I said, well, if R0 equals, that's the double equal sign, 2, that's telling me you never finished the job. So if I start this program again, I hit cycle start, remember it's telling me to start at 1. I'm going to go grab my part probe. Now in this case I'm starting everything from the beginning. You could, get much more complex with this concept and have it know which operation it was in and jump to that one. This method is what's known in the industry as structured programming. So this is just a very simple use case where now I don't have to worry about, if a program gets shut down mid-program, I can create this nice little logic to allow me to start her back up again and get right back to my job. All right, so let's take a look at our angel. We should have it cut. So I'm going to shut off my vacuum. I'll open up our doors here. Maybe bring in, had I let it go all the way through, it certainly would have cut all 6 of them. In this case, I now have my nice finished part. some of the chip. Now when I want to finish the rest of this plate, I'll just drop this angel back into that pocket, and just by it being there, it'll seal all that vacuum. So here we have it. We just cut our nice little angel, right? And then from there we can go into full production mode. So I just wanted to kind of have a little fun, show you guys some different scenarios, different options of how you could kind of methodize a job, and yeah, and just kind of fool around with it. So with that, let me take a quick look. I do see a bunch of comments here from friends and people I know. Awesome. Crazy how quiet the pump is. Yeah, it is super quiet. Even when I had it right here to my feet, you could barely hear it. What I do notice with these little pumps is they do kind of blow off a little bit of mist. You can even see kind of a little bit of smoke here. That was probably from, I had my mister going just to blow the air off, so you get a little bit of atomization. But you do see a little bit of that smoke come from the pump. That is normal. It's just kind of water vapor being pushed off. Well, I will be giving you guys all of the different models and the drawings, certainly for the vacuum chuck, in the little description area of the video post-event. I wanted to get the event done, and then we'll drop them up. But I certainly want to say, you know, Merry Christmas, Happy Holidays to all of you out there. I hope you a very Merry Christmas, Happy Hanukkah, Happy New Year, and certainly enjoy and best wishes coming forward. So with that being said, thank you all, and I look forward to hearing from everybody next year. All right, you have a great day. Bye-bye.